Okay, good morning, students.
Good morning, sir.
Good morning, sir.
Myself, Sadashiv Chakrasali. In department, everyone calls me SVC. That is my abbreviated name. All of you are able to see the board, what all the things I have written?
So we can see the board, but there's nothing written.
Nothing, okay.
Written something.
Nothing is coming, just 2 minutes. Maybe thickness, maybe more, that's why. Just a minute. Then everything is right. VNP ಇದು ಯಾಕೋ ಚೇಂಜ್ ಮೋಡ್ ಆಗ್ತಾ ಇಲ್ಲ ಡಿವೈಸ್ ಇವನ್ ಇದು ಮೊದಲು ಮೌಸು ಇಲ್ಲ ಪೆನ್ನು ಬರ್ತಿತ್ತು ಈಗ ಪೆನ್ನೇ ಇದೆ ಬಟ್ ಆದ್ರೆ ಕನೆಕ್ಟ್ ಆಗಿದೆ ಆದ್ರೆ ಪೆನ್ ಇದಾಗ್ತಾ ಇಲ್ಲ ನೋಡು ಮೌಸ್ ತರ ಬರ್ತಾ ಇದೆ ಚೆಕ್ ಮಾಡಿ ಇಟ್ಟಿದ್ದೇವಪ್ಪ ಪೆನ್ ಕಲರ್ ರೆಡ್
ಈ ಪೆನ್ನಲ್ಲಿ ಇದೆ ಅದು
ಇದೆ ನೋಡು ಈ ತರ ಮೌಸ್ ಪೆನ್ ತರ ಆಗ್ತಾ ಇಲ್ಲ ಅವ್ನು ಇವನ್ ಕರಿ ವಿಶ್ವನಾಥನ್ನ ಬಂತ ಬಿಡ ನೂತನ್ ಬಂತ ಬಿಡು ಓಕೆ dear students, I hope now you can see the board.
Yes, sir.
Myself, Sadashiv Chakrasali. Today I am starting the second unit. The second unit name is Linear Time Invariant Systems. Linear Time Invariant Systems. Please tell me, all of you are able to see it properly?
Yes, sir.
Yes, sir.
Okay, fine. So, before going to the linear time invariant systems, just I want, already in the previous unit you have discussed about the different sort of signals, their nature and their systems, their properties, all those things. So, I'd like to consider good morning. Let me consider that. This is my good morning. It is starting at t is equal to 0 up to certain time. Let me say capital T. Okay. Along the y-axis, I am considering the amplitude. Along the x-axis, time t. Okay. Suppose this is my SVC voice. Instead of SVC, if VNP is teaching you, Newton Prasad. Okay, I'm a little bit nervous today. So he has created lots of enthusiasm regarding the subject. And if the VNP wish you good morning, how it will be? Maybe something like this. Okay. So now tell me, what is the difference you are finding out? Of course, the pitch frequency and those things will be different, but just uh, considering the third semester understanding level, what differences you are finding out in these two signals?
Time, like
Time.
time
Okay.
delivered between both the speed.
Amplitude.
Amplitude, sir.
Amplitude is different. Okay. Amplitude is different. So normally whenever he is talking, he speaks with the high amplitude. Okay. So that difference you are finding out in that signal. Now tell me whether these two are periodic signal, sorry, power signals or energy signals, or neither power nor energy. What sort of signals these two are?
Sir, energy.
Energy signals. Okay. One student has given the answer that it is a both are energy signals. Okay. Can you tell me? Can you justify? Can you
Sir,
tell?
because they are finite.
Ah, whenever you are having a finite duration signal, whenever you are having a finite duration signal, obviously they will be finite energy signals. Okay. So that's why these are energy signals. Okay. Now here I'm indicating t is equal to 0. T is equal to 0. What does actually it corresponds to? Means what do you mean by t is equal to 0? Is it referring middle night 12 a.m.? Is it referring anything?
Sir, our reference at which we started to consider the signal, the
Okay.
reference
It's
time.
the reference time. Okay. Now suppose if we are starting the our class at 11 o'clock, if we are starting the class at 11 o'clock, 11 o'clock is the my time t is equal to 0. That is my reference time. 10:50, 10:45 or 9 o'clock, they are the left side of this t is equal to 0. It's a reference time. Suppose if I'm starting my class at 11:15 a.m. So previous to that, it may be yesterday, day before yesterday, whatever it may be, left side is previous thing. And next one is the positive t indicates the next it is going to happen. Okay. Now, suppose if I consider at 12 o'clock here, let me say 12 a.m. That is going after this time. Okay, whatever the time is here, after this time, the 12 a.m. is going to come. That's it. Okay. Now, I have told you two important aspects. Okay, just considering the signals, whether what sort of nature they are possessing, and I have told you this t is equal to 0. Now, let me consider time invariant systems. Before going to the time invariant system, let me consider linear system. What do you mean by linear system?
It obeys superposition theorem.
Sorry,
If it satisfies superposition theorem, then it is called linear.
a system which obeys the superposition theorem.
Yes.
Okay. Now let me say, see here, whenever I'm writing whatever the discrete time or continuous time representation I'm giving, that holds good in another part, same thing. Okay. Suppose if I'm writing x of t, so instead of x of t, I can consider x of n also, where x of n is the discrete time input signal. Now, if I am giving x of x1t as an input to the some LTI system, okay, then I am getting some output y1t. Similarly, for the same system, if I give the x22 as the input, the same system, whatever the LTI system is here, for the same LTI system, I'm giving, or just let me say, even no need to consider LTI system. Let me consider one system. That's it. Okay. Just I want to consider system. For that system, I'm giving the x1t as an input and I'm getting y1t as an output. For the same system, I'm giving x2t as an input. Then assume that I'm getting y2t. Then I will consider a new signal x3t, where x3t is the some linear combination of the x1t and x2t. Let me say some constant a times x1t plus b times x2t. I'm giving this as an input to the system. Then I'm getting some y3t. If this system is LTI, if system is LTI, then what about the y3t? What you can say about y3t? Yes, I hope you are able to follow me.
Yes, sir.
Okay.
It should be some linear combination of A1, Y1t and Y2t.
Yes. Y3t must be A times Y1t plus B times Y2t. Then such system is considered as the LTI system. It satisfies the superposition theorem. Okay. And now for this system, assume that I'm having a particular system. I don't know whether it is a LTI system or non-LTI system. I will consider x of t as the input, and I am getting y of t, where y of t is nothing but 2 times x of t plus 3. I am getting y of t is equal to 2 times x of t plus 3. Now tell me whether it is a linear system or not.
It's not linear, sir.
No, sir, not linear.
Okay. First one girl has told that this is a linear. Who is that?
No, sir, I said non-linear.
Non-linear. Okay. Anybody is saying that it is a linear? Anybody is there who can say that this is a linear system? Will it satisfy superposition theorem?
No, sir.
It won't.
No, sir.
Okay. See here, there is a, to check the linear system, we have to check another important factor that is known as the homogeneity. What is that? Homogeneity. What is that homogeneity? Yes. What is homogeneity? Have you heard this or not? Have you heard? Dear students, please respond.
So does it mean that all the variables of x should have the degree 1?
See here, obviously linear system means it should have a degree 1 only. It should have a linear relation with respect to the input. Okay. Always your output should have a linear relation with respect to input. That is obvious. Okay. Who is asking that doubt? You please tell your name. Nothing to worry. Okay. Please respond. Otherwise, I cannot go ahead. Homogeneity, have you heard it or not?
So mathematically, it means if we have a combination or an equation or anything of more than two variables, the constant associated will be 0.
Okay. See here variable is only one. X of t is the variable. X of t is your input. Y of t is dependent on x of t. It is having some linear combination. Huh?
Yes, sir.
Then you can say linear or non-linear.
Sir, constant is there.
Which constant you are talking about?
So
3.
the signal is linear, but the system is non-linear.
Signal is linear, system is non-linear. Which signal you are talking about?
So 2x plus 3.
2x plus 3. That is your outcome. Okay. See here, this system is non-linear. The reason is it is not satisfying the homogeneity. Okay.
Yes.
Homogeneity. What is homogeneity?
So,
Whenever
all,
x of t is
yeah.
0, whenever x of t is 0, then your output y of t must be 0. But you check it in here, in this condition, when x of t is 0, what is going to happen for the y of t?
It will be
3.
3.
It will be 3.
Okay, when x of t is 0, your y of t is 3. That's why this system is non-linear. Okay, now I forgot to tell you another important parameter. That parameter is known as the dimension of a signal. Let me consider the previous slide, whether it is there or not. Yeah, it is there. Now you see here. Now here I am having two waveforms. Okay. Now I'll ask you, what is the, okay, let me consider any one signal. What is the dimension of the signal? Can you tell me the dimension of the signal? Have you come across the dimension?
No,
Please
sir.
respond. No or yes?
Yes,
No,
sir.
sir.
No, sir.
No. Okay. Dimension means, see here, what is signal?
Function of one or more independent variables.
Yeah, function of one or more independent variable. Now, let me consider a cosine signal. What is this? Cos of t or cos of omega t. Suppose if you are considering x-axis as a t, then it will be cos of t. If you are considering in terms of the radians, then it will be in terms of the cos of omega t. Okay. So, now this, whatever the x of t is there, x of t is a function of time t. So t is an independent variable. What is t? T is independent variable. Okay. So number of independent variables defines the dimension of the signal. Understood? The dimension. Oh. So here, what is the dimension? What is the, how many free variables are there? Time. My signal, whatever the speech I'm talking about, it is varying with respect to time. Suppose if I draw a cosine signal, let me consider x of t is equal to cos omega t. X-axis is varying with respect to, is varying in time. So omega is some constant angular frequency. Then see here, my x of t is dependent on the t. So t is an independent variable. T is independent variable. So how many free variables are there in the signal x of t?
1.
1.
Only one. So what is the dimension of the signal?
1 dimension.
Yes, the dimension of x of t is 1. Now can you give me the example of two-dimensional signal?
Images.
Very good. Who is that? Please tell me your name.
Anaga, sir.
Anaga. This name I heard several times, at least in a single period. VNP used to call some 10 to 20 times. Okay. So let me say that this is an image where I'm having some car, something like that. Okay. So this is an image. So can you tell me the variables, Anaga, or anybody else?
Coordinates of that pixel.
Coordinates of the pixels. I can say x and y is varying here. Suppose if I say these are the pixels, okay, they are adjacent. Okay, the intensity of this pixel, of course, that is the magnitude, amplitude. Okay, the intensity of this pixel is magnitude, whereas it is indicating the spatial variation of the x and the spatial variation of the y. X direction and y direction, how much it is, where it is located. Here I am having, suppose if I consider this pixel, it is having, let me say 128 comma 10, y value is 10, whereas x is 128. Let me say, so it is a function of two values, x and y. So that's why it is a two-dimensional signal. Your image is always two-dimensional signal. Got it? Okay. Now, can you give me the example of the three-dimensional signal? Of course, all these things are might have been explained in the unit 1. Just I'm taking some time so that I can become familiar with you people.
So color codes of colors,
Sorry?
color codes of colors because they are combination of three
Of
colors.
colors? No,
Depending
no,
on the
no, no, no.
Sir,
No.
sir, visible light or electromagnetic radiation.
Who is that? Who is giving the example of electromagnetic radiation?
Sir, Vinayak.
Vinayak. Okay, I'll come back to you. Okay, Vinayak,
Okay, sir.
just 2 minutes. Okay, two-dimensional. Sorry, two dimension is over. One dimension is over. Now three-dimensional signal. Anybody? Huh?
So movies.
Who? Very good. Who is that?
So Vishnu.
Vishnu. Okay. At this point, I would like to remind you one thing. I hope everyone might have seen the movie Tare Zameen Par.
Yes,
Hmm?
sir.
Have you seen the movie Tare Zameen Par?
Yes, sir.
Okay. In that one, a little boy has written a picture. He has written that picture in the form of book. Actually, he is departing from his parents. Okay. In one frame, what he has written, his parents are standing here. That boy is standing somewhere here. In the next frame, what he has written, those three people are standing there itself, but this boy is standing slightly away from them. In the next frame, still away. I hope all of you are getting this image.
Yes, sir.
Yes, sir.
Then these frames are interleaved over a time. See here, x and y is there. In each frame, x and y is there. Along with that, they are interleaved with respect to time. The time is varying. So you will get a feel of that boy is moving away from that family. Please tell me, you're feeling that? You're
Yes,
able
sir.
to recall it?
Yes, sir.
So how many variables are there? One is x and y, another one is time t. So it is a three-dimensional signal. Whenever you consider any video, it is a three-dimensional signal. Got it?
Yes, sir.
Okay. I'm hearing the response only from the one or two students. Hmm? Everyone is able to hear me or
Yes, sir.
Yes,
You
sir.
are audible.
otherwise I'll randomly call the USN. Hmm? USN number 85. Okay. Now I'll ask you, give me an example of four-dimensional signal. Practical signals of four-dimensional signal. Vinayak or Vinay.
Yes, sir.
Can you give me the example of four-dimensional signal? Hmm?
Sir.
Hmm? Yes, come on.
Sir, is it, like a 4D movie, sir?
4D movies. I don't know about that 4D movies and other things. The best example is your electromagnetic signal, the four-dimensional. Suppose, assume that you are having your antenna somewhere here. Okay, your antenna is here. You are transmitting. Assume that your mobile, you are calling. Your location is here. I hope you are able to see my pointing location.
Yes, sir.
Now you are talking to your friend. waveform will go in this direction, somewhere like this. Okay, it is going like this. So in a space, how many coordinates will be there? It is having a spherical coordinates. It is having x-axis value, y-axis value, and z. Yes or no? Now suppose
Yes.
assume that you are standing at the one of the corner of your room. You are keeping your mobile there and you are radiating the signal. It can go in any direction, that signal. So it should give you the x coordinate, y coordinate, z coordinate. Along with that, it should have the time t also. It is reaching. Suppose if you are in the corner, to reach 1 kilometer, it may take some time. To reach the 2 kilometer, it may take some another time. Okay. So t is another variable. X is one variable. Y is another variable. Z is another variable. Total 3 variables. Those are the spherical coordinates or spatial coordinates. Along with that, time is also there. So how many variables are there? Free variables. It is x, y, z and time r theta phi. Right now, do you have the electromagnetic signals, electromagnetic subject in third semester?
No,
No.
sir.
No. Okay. It may be in the fourth semester. There you will come across. Okay. Different representations are there. So normally the spherical coordinate system, normally you need x-axis, y-axis, z-axis along with the time. So 4 variables are there. So electromagnetic wave is the example of 4-dimensional signal. Okay.
Sir, double slit experiment, and that can we say?
Double
Double slit experiment.
you have conducted in physics.
Yeah, we had in physics, sir. Like,
Okay. Regarding that, I don't know, pa. I don't want to comment on that one. Okay. Without knowing that, I should not tell. Please excuse me. I will try to understand it. Your slit experiment, what it is. I will inquire with the physics faculty and I'll let you know about it.
okay.
Hmm? Okay. Shall I go to the next slide? I will take up new page. Okay. I hope you have understood just one class of energy signal, then independent variable, dimension, then after that linearity, homogeneity. Have understood or not?
Yes,
Yes,
sir.
sir.
Okay, fine. Now assume that I'm having a LTI system. It is a LTI system. For this system, I'm giving x1t as an input, where x1t is like this. 0 to 1, it is 1, and afterwards it is 0. Okay, it is a pulse. Okay. Then assume that you are getting y1t something like this. Okay. All of you are able to see this?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Fine. Now I'm saying that this is a LTI system. For this system, I will change the input. I will give the input as a something like this. From 0 to 1, it is 1. From 1 to 2, it is 0. From 2 to 3, it is -1. Now, what will be the output? Did you understood my question? I'm having a LTI system. For that LTI system, I'm giving x1t as an input. When x1t is the input, I'm getting the y1t as this output. This output. Now, I'm giving this as an input, x2t as a new input. Then what will be my output y2t? Is it possible to find it out?
Yes.
Yes, sir.
Okay. Now, I'll give you 2 minutes time. Just 2 minutes time. How it will be, you can tell it orally, or you can draw it and you can turn on your cameras and you can show it. Anybody has finished? I don't think it requires that much time. Yes?
Yes.
Okay, how it will be?
So
How it will?
does it remains same from 0 to 2, the
Ah,
output signal, and from
ah,
2 to 4, it will be magnitude inversion and the negative half. Is
negative.
it like that? Huh.
I will write, now you tell me whether it is same or not. From 0 to 1, it is increasing. From 1 to 2, it is decreasing. From 2 to 3 also it is decreasing, but it goes in the negative magnitude. Is it something like this you're talking about?
Yes, sir.
No, sir.
No?
From
Okay.
2 to 4,
Then you tell me.
0.
Yes.
2 to 4, 0, sir.
2
Yes,
to
sir.
4,
From
it is 0.
0 and 4
Yes,
to
sir.
6
Then after
negative.
4 to 6, negative.
Yes, sir.
Yeah.
Uh, okay. Who said that? 2 to 4 negative, 2 to 4 0 and 4 to 6 negative. Hmm? Hey, come on, tell me your name. Nothing is going to happen.
Suprit.
Suprit. Okay. Now, can I write x2t? What is x2t actually? If you look at the, in comparison with x1t, I can write x2t is nothing but x1t plus x1 of t minus 2. Sorry, not plus, it is minus. Is it right? x2t is equal to x1t minus x1 of t minus 2. It is shifted by the 2 units and magnitude is inverted. Is it right? Yes or no?
Yes. Yes, sir.
Yes, sir.
Yes, sir.
I'm giving this signal as an input to this system. Then what sort of output I should get? It is a LTI system, you know. It is a LTI system. Now my new output y2t will be obviously nothing but my y1t minus y1 of t minus 2. What is a time invariance? Whatever the amount of time delay I am introducing in terms of the input, the same amount of delay is going to occur in the even in the output also. So here my input x1t is delayed by 2 units time. So my output should be also delayed by 2 units of time. So this is nothing but my y2t is equal to y1t minus of y1 of t minus 2. So what is y1 of t minus 2? The same signal, whatever the signal is here, that should be delayed by the 2 units. It should be shifted towards the right side by an amount of 2 units, but magnitude should be inverted. So this is the right answer. Samarth or whoever has said that this is wrong, did you understood?
Yes, sir.
Got it? USN 53, he has joined now only, just some 5 minutes back. Are you able to understand this?
Sir, it's another device actually.
Okay. Now
Sir, which one is correct, sir?
we
The
will
one
come
with
to
another
unit
side or the
2.
one with... Sir, hello?
Now let me consider the signal. Let me consider some example signal. Assume that I am having x of n, where x of n is equal to, let me change the color. I'll consider it as a blue or something else. Okay. So assume that this is my signal 1, 0.5. What is this x-axis? X-axis is t or something else?
And
N. Yeah, can n take the real values? Or what sort of values it can take?
Integer values.
Integer
Only
values.
integer
Integer
values.
values.
Okay. This is 0. This is 1. Let me consider another sample existing at n is equal to 2. Let me say that value is 1 by 4 or 0.25. Next one is at n is equal to 3. This is 1 by 8 or 0.125. I hope you are able to see these values properly. Now I am having x of n. This is my graphical representation. Now I'll give you the mathematical representation or another way of representation, that is 1, 0.5, 0.25, 0.125, then 0, 0, and so on. This is starting at n is equal to 0. This arrow indicates what?
80.
The reference point.
Reference point. Very good. Okay. So now, can you write this x of n as a linear combinations of the unit impulses?
Yes, sir.
Okay. Then you tell me the linear combinations.
It will be delta of n plus 0.5 delta n plus 0.25
Okay.
delta n.
Okay. X of n can be written as delta of n plus 0.5 times delta of n minus 1 plus
Correct.
0.25
0.25
times
delta of
delta of
n minus
n
2.
minus 2 plus 0.125 times delta of n minus 3. Okay. Plus only that much? Huh? Any other
Sir,
equal? Not there?
1 by 2 power k times delta of
Ah,
n minus k
very good.
in general, sir.
Okay. Who is that? Who has given the general answer?
Vishnu.
Vishnu. Okay. See here. Yes, I agree with you. But yeah, whatever you answer you have told, it is right only. Just I want to elaborate this. Okay. So wherever the impulses are having the zero coefficients or zero magnitude, just I will ignore them. Then I will be getting only delta of n plus 0.5 times delta of n minus 1 plus 0.25 times delta of n minus 2 plus 0.125 times delta of n minus 3. So this is nothing but the linear combinations of the weighted impulses. If you consider any signal, any discrete signal, you can consider as a weighted sum of the impulses. Okay. Similarly, even in continuous time domain also, you can write the any signal as a linear combinations of the impulses in continuous time domain. Now, here I would like to explain you one important concept that is known as the convolution. Convolution is the what I can say important property or implicit property of the LTI systems. Okay, if you are having non-LTI systems, you cannot have the convolution at all. Okay, now assume that you are having delta of n as an input. You are having delta of n as an input, and this is my LTI system. In unit 2, we are only discussing about LTI systems. Okay, we are not discussing anything about the non-linear or time varying system. We are considering only LTI systems. So now my input x of n is equal to delta of n, and I am getting some y of n. See here, normally instead of using this square bracket for the discrete time signals, I use this normal brackets only. Okay, if you are getting confusion, you can use the rectangular bracket, no, square bracket only. Okay, which one you prefer?
I guess fine, sir.
Anything will be fine, sir. Anything is fine.
Anything is okay? Okay. Always answer is given by Anaga, Vishnu, and another one or two candidates. Response is also given by them only. What about others? Turned on the system and sleeping?
Sir.
Huh?
Hello, sir.
Not like so? Okay.
No, sir.
Sir.
My input is impulse, unit impulse. Then I'm getting some output. That output is considered as the h of n. So what is that h of n? In your signals and systems, h of n is having a specific meaning. Okay, in your EC34, am I right? The code of the subject is EC34, EC35.
35. 35.
35. In EC35, whenever we speak h of n, it is having a specific meaning. You cannot consider anything else. That is impulse response of a system. What is that? Impulse response of a system. Okay. This is a LTI system. We will not say that impulse response of a LTI system. Just we'll say that impulse response of a system. Of course, if you want more specific, you can say impulse response of a LTI system, but normally that we'll ignore the LTI. It's the impulse response of a system. We are giving impulse as the input, and the corresponding response, whatever the response we are getting, it is impulse response. Clear? So what is the meaning of h of n?
Impulse response of a system.
Okay, fine. Now, here I'll give you one example. Assume that you are having a LTI system. For that LTI system, I'm giving impulse as an input, and I am getting impulse response as a h of n as a, what is the h of n? I am getting something like this, 1.5, 0.25. Just 3 samples are coming out. I am giving one sample as an input. At n is equal to 0, I am giving, oh sorry, please remind, I have changed the slide, but okay. See here, I am having a LTI system, delta n. Screen is disturbing you?
So can you remove that black thing, sir?
I don't know. Sometimes automatically it comes. Okay.
Right
So
below it, no?
I'm not able to drag this also. I don't know what is there.
Just leave that part and right below that.
Okay, okay. Okay. Assume that you are having a delta of n. This signal is given as an input to the LTI system, some LTI system, and you are getting the output. That is, of course, whenever you give the delta of n as an input, your response of a system will be always h of n. Assume that h of n is something like this. How it is? Something like this. 1 at n is equal to 0. At n is equal to 1, it is 0.5. At n is equal to 2, it is 0.25. Next, 0. Here at n is equal to -1 also, it is 0. Okay. You are having something like this. This is the impulse response of a system. Now, I will consider a new input. So what will be my new input? Assume that I am having x of n. X of n is something like this. One, 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 between 0, 1, 2. For 3 it is 0, at -1 also it is 0, at 4 also 0, like this. Now suppose if I give this as an input, what will be my output? When I give delta n as an input, I am getting this output. When I am giving this as an input, what will be my output?
Sir, 1, 1, 1. After that 0.5, 0.25.
Okay. Who is that? Who has given the answer?
Sir, Aditya.
Aditya. No, it's wrong. Anybody else?
Sir, the same thing but 3 times.
Same thing but 3 times. Okay. That is also wrong.
Only 1, 1, 1.
Only 1, 1, 1. No.
It is
Anybody?
like 1, 1.5, 1.25, and then decreasing.
1, 1.5, then 1.25, then decreasing.
Yeah.
Okay. Who is that? Who has given that answer?
So Gyan.
Gyan. You are right, but can you tell me how?
So cause it's so at each step it's increasing from point. It's adding up. The signal is adding up to 0.5 then 0.25. So it's earlier it's 1, so it'll add up to 1.5, and the other will be 1.25, and then decrement will occur.
Okay. Shall I consider this x of n as nothing but delta of n plus delta of n minus 1 plus delta of n minus 2? Can I consider like this? Yes or no?
Yes, sir.
Yes, sir.
So, when I am giving this delta of n as an input, my output will be h of n. Right? Yes or no? What is this? Delta of n minus 1. I am giving this as an input since it is a LTI system. So, what happens to this? The output corresponding to this impulse, what it will be? My x of n is linear combination of delta of n minus 1 and delta of n minus 2. So, what will be my output? It is h of n. What is the output for this one corresponding to delta of n minus 1?
H of n
H
minus
of
1.
n minus 1. Yes, very good. It is h of n minus 1. What will be the output for this delta of n minus 2?
H of
H
n
of
minus
n
2.
minus 2. So, this is your y of n. So, if you want to find out y of n, this y of n is nothing but, so first h of n. How is your h of n? So your h of n is like this: 1, 0.5, 0.25 taken at 0, 1, 2. Okay. Next, I'll change the color. So this is your h of n. This is the output coming due to delta of n. Now due to delta of n minus 1, I am getting h of n minus 1. What is your h of n minus 1? What happens to h? What is h of n minus 1? You are having h of n. Then what will be h of n minus 1?
Delay,
Start
sir.
from
It will
1,
start.
it'll start from 1 to 4.
Reference
1
point
to
will be
3.
shifted towards the right side by how much amount?
1.
Towards the right side by amount of 1. So your 1 will come here. This is your h of n minus 1. So h of n minus 1 means here it is 1 at n is equal to 1. At n is equal to 2, it is 0.5. At n is equal to 3, it is 0.25. Yes or no?
Yes.
Okay. Next, still h of n minus 2 is there. I'll change the color for that. Okay. So, if I consider h of n minus 2, the same h of n is shifted towards the right side by an amount of 2 units. So, where whatever the sample is existing at n is equal to 0, it will come at n is equal to 2. So, at n is equal to 2, it is 1. At n is equal to 3, it is 0.5. At n is equal to 4, it is 0.25. Then at n is equal to 5, 0. At n is equal to 1 also it is 0. So you are having h of n, you are having h of n minus 1, h of n minus 2. Now can you add all these together? Oh, it is light. So if you add them, here at n is equal to 0, this is 1. Here it is 0. Here also it is 0. So you will get 1, 0, 0, that is 1. Okay. Next, at n is equal to 1, this is 0.5, this is 1, this is 0. So it will become 1.5. At n is equal to 1, it is 1.5. At n is equal to 2, this is 0.25, this is 0.5, this is 1. So how much it will be if you add them? 0.75 plus 1. It will be
1.7.
1.75. So just please at n is equal to 3, this is 0.75. At n is equal to 4, this is 0, this is also 0, and this is 0.25. At n is equal to 5, all are 0, so 0, 0 only. Understood or not? Did you understood?
Yes, sir.
Yeah.
Okay. What is this? This is nothing but convolution. What is this? Convolution. Okay. What is convolution? Normally, I ask this question in the Viva in the lab exams for DSP. Every time students tell that, sir, we will do the multiplication, we will do the addition, all these things. It's a method. See here, convolution means it is a method to find out the response of a LTI system, response of a LTI system for the given input, provided we know the impulse response. If you know the impulse response of a system, LTI system, then for the any input signal can be represented as a linear combinations of the impulses or delayed impulses, and thereby we can obtain the output of the system corresponding to the given input. That is convolution. Okay. Dear students, tell me, understood or not?
Yes, sir.
Okay.
Sir. Hello, sir.
Tell me.
Sir, I had a doubt in previous pages. Can you revert back?
Okay, sure.
Previous one.
Still previous?
Yeah. Yes, sir. In that signal, the square wave signal, what if
Pulses.
the delay was -1? What would the output look like?
1 second. Just I'll come back. Who is that person?
You want my name?
Yeah. Just
Shreyas.
I don't have familiarity. Just I want to have familiarity with the names. That's it. Nothing to worry. Okay. See here, you can ask 100 doubts. It's not a problem for me. Okay, don't disturb my class. That's the only thing. But regarding doubts, you can stop me at any time and you can ask the doubts. What was your doubt? Instead of having the 1 unit delay, if it was having 1 unit advancement.
No.
That is your question?
The delay here is 2. What if it was 1?
What if?
The delay was 1.
Okay. That means you want to consider like this. Okay.
Yes. What would the output look like?
Okay. Then what happens? This, see here, whatever is here, this. You're able to see that where I'm moving my cursor?
Yes, sir.
Okay,
Yes.
this will be as it is. But due to this, it will come like this, negative.
Okay.
It will start from 1 to 3. Then what is going to happen? This is 1, this is 0. So it will be constant. It will be constant from 1 to 2. And then from 2 to 3, it will be going like this. Okay. Suddenly, it will, from 2 to 3, it will come to negative. From negative -1 to, it will go to 0. It will be like this ramp. But this ramp will be existing between 2 to 3. But the magnitude is going to be changed. I will just write it like.
Sir, could you draw a rough figure there?
Okay. I will write it. Okay. Other students, you are able to understand what he is asking. Sorry, I forgot your name.
Shreyas.
Shreyas. Okay. You are having a LTI system. For that LTI system, you are giving this input. Okay. This is your x1 of t. This is t between 0 to 1. It is 1. And you are getting the output y1t. That y1t looks like this. It's 0, 1, 2. Its magnitude is 1. Okay. Right? Now, for the same system, if I change the signal, like this, you are asking between 0 to 1 it is 1, from 1 to 2 it is -1. This is my x2t. Am I right, Shreyas? Your question is like this?
Yes, sir.
Then what will be the output? He is asking. See here, this you can write x2t is nothing but x1 of t plus x1 of t minus 1. Yes or no?
Minus x1 of t minus 1.
Sorry. Thanks for correcting me. Okay, minus of x1 of t minus 1. When you give this as an input, you are getting, see here, whenever x1t is going, it is giving you y1t. Whenever x1 of t minus 1 is going as an input, obviously it should give you y1 of t minus 1. But negative sign is there. So your output will be like this. From 0 to 1, it will be increasing. So this is y1t, but there is this is 1, this is 2. But along with the y1t, I should add another concept, another component. What is that component? y1 of t minus 1. y1 of t minus 1 means whatever the 0 is there, that should be shifted to 1. So it will be like this. From 1 to 2, it will be decreasing. From 2 to 3, it is going from increasing and it is reaching the 0 value. Okay. Now here it is 1. Here it is -1. You add these two signals. You have to add these two signals. So if you add these two, from 0 to 1, it will be as it is. From 1 to 2, its magnitude will be varying. See here, this is how much it is. Let me say at 1.1. At 1.1, this is 0.9. Here it is -0.1. Just I am assuming like that. So 0.9 minus 0.1, how much it is? 0.8. Next at 1.5, let me say at 1.5, this is 0.5, whereas here it is -0.5. So how much it will be? If you add these two, it will be 0. Okay. So it will be something like this. Roughly I am sketching. Shreyas, it is going from 0. Then this is 1, this is 2. So it will be like this. From 0 to 1, it goes on increasing. From 1 to 2, it decreases. Okay. Next, from 2 to 3, it will be going like this. It is finally it will be reaching this. Is it making sense? At 1.5, it is crossing the 0. Shreyas,
Clear, sir. Thank you.
understood?
Yeah.
Okay. Anybody else?
Sir,
Ah,
sir, is there any particular definition, or just could you repeat whatever you told about the convolution, sir, the final statement?
I will tell you. I will explain. Nothing to worry.
Okay.
I'll give you. And one more thing. I think Nutam Prasad used to give you notes. He used to dictate the notes. Okay. But normally I don't do. So whatever I'm going to write on the board, you please note down that. Okay. I don't have the habit of giving notes. You are expecting me to give the notes, everyone?
No, sir.
It's a completely problematic subject. Okay. It is not so hard as much as amplitude of the Nutam Prasad. Don't be afraid of that. Very nice and interesting subject. Shall I proceed?
Yes, sir.
Okay. Now I'll come back to the definition of the convolution. I'll give you the mathematical representation. Then I'll solve some problems, numerical examples. Okay. Now let me consider any signal x of n. X of n is how it will be. See here, suppose if I consider x of n at n is equal to 0, its magnitude will be x of 0. Do you agree? At n is equal to 1, its magnitude will be x of 1. At n is equal to 2, its magnitude will be x of 2. Something like this. Yes or no? This is a kind of signal representation. Suppose at n is equal to 100, if you say at n is equal to 100, this is x of 100. Its magnitude is like this. Okay. So any signal x of n can be represented as a linear combinations of the delayed impulses. Now let me consider at n is equal to -1. I'm having its magnitude -4. So I can write this is nothing but x of n, x of -1 is equal to -4. So any signal in general x of n can be represented as dot 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 plus x of -2 into delta of n plus 2 plus x of -1, its magnitude. See here, x of -2, x of -1, whatever I'm writing, it's corresponding to their magnitudes of x of n, and their interval, timing instant. Timing instant is denoted by delta, impulse function. So x of -2 delta of n plus 2, x of -1 into delta of n plus 1, plus the magnitude at n is equal to 0 is x of 0, and it is existing at delta of n, plus x of 1 into delta of n minus 1, plus x of 2 into delta of n minus 2, and so on. Can I write like this? Any signal, any discrete time signal. And today I'm not at all talking about the continuous time signals. Okay. If I want to explain convolution in terms of the continuous time signal, it will be slightly tedious. So it is easier for you people to understand the convolution concept with respect to discrete time signal. Please tell me, can I write any signal, any discrete time signal x of n like this? Yes or no?
Yes, sir.
Yes, sir.
Okay. So can I represent this x of n something like this? X of n is equal to summation over k is equal to minus infinity to infinity x of k into delta of n minus k. You can substitute different values. Let me say k is equal to -2 to +2. You substitute and check it whether I will get the same thing or not. Dear students, you can choose
Yes,
k
sir.
is equal to -2 to 2. Just for an example, you try to substitute those values. When you substitute -2, x of -2 into delta of n minus of -2. So it will become delta of n plus 2. So any signal x of n, discrete time signal, can be represented like this. Very good. One of the student is coming now after 1.5 hours. Right?
Yes, sir.
Okay. Now, my x of n, can be written as summation over k is equal to minus infinity to infinity x of k into delta of n minus k. Where these are x of k indicates the magnitude of those impulses. Those impulses are existing at the instant given by impulse function. Now I will give this as an input to the LTI system. Then what will be my y of n? Hmm? I'm asking something. What will be
Sir,
my
is
y
it
of?
summation k equals minus infinity to infinity, h of k into h of n minus k or something? Or I
Anaga?
guess that is wrong. Yes, sir.
Okay. Let others to think.
Sir,
Ah,
sir, it will be the impulse response of this entire thing, sir, like h of the summation.
uh-huh. Okay.
Sir, one example should be given so that you can find a y of n.
Sorry?
One sample example should be given, sir, like in above example.
I'm giving you general expression. One example already over. I have given you 1.5, 0.25, and then I have given the three input like a 3 ones for n is equal to 0 to 2, That is an example of convolution that is already done. Now I want to explain you the general concepts,
So
general
summation,
expression.
So summation k tends to minus infinity to infinity x of k and h of n minus k.
Who is that?
Pradeep
Who is
sir.
that? Huh?
Pradeep sir.
Pradeep. Okay.
Yes, sir.
Very good. Have you seen any textbook or you have just guessed it or?
Guessed it, sir. X will be same and delta will be interchanged by h, I think.
Very good. Very good. Okay. But today, unfortunately, I am not able to hear Prakar. Prakar's name. Okay. Whoever has given the answer, that is very correct. See here, your x of n can be written as dot 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 x of minus 2 into delta of n plus 2 plus x of minus 1 into delta of n plus 1 plus x of 0 into delta of n plus x of 1 into delta of n minus 1 plus x of 2 into delta of n minus 2, where these values x of minus 2, x of minus 1, x of 0, x of 1, x of 2, these are the magnitudes and they are existing at n is equal to minus 2, this is existing at n is equal to minus 2, this is existing at n is equal to minus 1, this is existing at n is equal to 0, this is existing at n is equal to 1, this is existing at n is equal to 2. So your final output will be dot 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 plus this magnitude will be maintained as it is. What is that? It is x of minus 2. But this impulse will give you what sort of output? For this input, this delta of n minus n plus 2, what will be the output of this LTI system? It is, yes, anybody?
Impulse
H of?
Impulse response, sir.
No, 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 not impulse response. It is impulse response advanced by 2 units. H of n plus 2. It will be
Yes, sir.
x of minus 2 into h of n plus 2 plus x of minus 1 into, what is the response of this? H of n plus 1 plus x of 0, the response of delta n is h of n plus x of 1 into delta of, sorry, not delta, h of n minus 1 plus x of 2 into h of n minus 2 and so on. So I can write this one as summation over k is equal to minus infinity to infinity x of k into h of n minus k. Can I write like this?
Yes, sir.
Yes or no? Please tell me, all of you are able to understand?
Yes, sir.
I'm not able to hear you people.
Yes, sir.
Yes,
Okay.
sir.
So now I can write this one as x of n, the symbol star h of n. My y of n is nothing but summation over k is equal to minus infinity to infinity x of k into h of n minus k. That can be written as x of n star h of n. See here. Here I am putting star. What is that star? Star indicates convolution in your signal processing topics. Whether you consider DSP, digital signal processing, statistical signal processing, any higher signal processing subjects or your signals and systems, star means it is having a particular meaning. It is not a multiplication. It is considered as the convolution. Okay. So y of n is convolution between x of n and h of n. So mathematical representation is this. Okay. Clear?
So can't we write y of n is x of n convolution h of n minus 1, sorry, n minus k or something like
No,
that?
no. Whenever you are representing like this, it is just you have to write x of n convolution with h of n. It is a symbolic representation. This is mathematical representation. Okay.
So for n minus 1 also it remains same. X of n minus 1 convolution h of n minus 1 for all time shifting.
Don't make complexity right now. Okay. If you consider x of n convolution with the h of n minus 1, it is different. Okay.
Okay.
You have to delay the actual given impulse response, then you have to convolute those two. Okay.
Okay, sir.
So the symbolic representation of convolution of any two signals is given like this: x of n star h of n, or x of n x1n convolved with the x2n, like that. But this is mathematical representation. Whatever the summation I am indicating, that indicates the mathematical representation. Now assume that your x of n is of length L. It is of length L. And your h of n is of length m. Then the output y of n will have a length capital N is equal to L plus m minus 1. It will be the resulting sequence y of n will be of length capital N, that is equal to L plus m minus 1. Now we will verify this, whether this equation is correct or not. We will consider the previous example, whatever we have done. Unknowingly we have done the convolution. Okay, look at here. So what is the length of your h of n? This is your h of n, you know, where my cursor is moving. This is your h of n. What is the length of h of n? What is m value here?
3.
Come on, yeah, please response. Give me the response.
3, sir.
Hey, your volume is very less, it seems.
3.
Okay, 3. What is the length of the input x of n here?
2.
Hey, come on, 2. Is it 2?
3, sir.
This is also 3. It is existing between 0, 1, 2. So total length is 3. Non-zero values you have to consider. Okay. So now this the length is L is equal to 3, M is equal to 3. Then what will be the length N, convolution length? N is equal to L
5.
plus M minus 1.
5.
That is 3 plus 3 minus 1. That is 5. Now you check here. You are having this one sample here, another sample here, third sample, fourth sample, fifth sample. Is it giving you 5 samples? Yes or no? Here you are getting 5 samples. Yes. Okay. Now we'll come back to this. Now we have understood what is the symbolic representation of convolution. Then we know the mathematical representation. Then we have understood the lengthwise. What is the formula? Then how to do this? Now every time, suppose if I'm having that x of n, it is of length infinite length. Then is it possible for me to substitute in this mathematical representation? I'm supposed to keep on substituting x of k, where k is taking the values from infinite values. Is it possible for me to do the infinite calculations?
No, sir.
No. Then we should have some method. Okay. That method I'm going to explain now. What is the method? Method to find out the convolution. Now we have understood that whenever I want to find out y of n, my y of n will be always equal to summation over k is equal to minus infinity to infinity x of k into h of n minus k. Okay. So This is nothing but x of n convolved with h of n. Now, step 1. Assume that x of n and h of n are given. Okay. Then what you can do? You have to fold the signal h of n. First, you transform them into the k domain. Earlier, whenever x of n and h of n are given, you will consider the signals like this. This is n, this is also n, this is your x of n, then this is your h of n. Instead of that one, you transform them into k domain. That means just I'm changing the independent variable. Earlier, my independent variable was n. Now, my independent variable will be k. Just I will consider x of k and h of k. Nothing is going to be changed. So whatever the earlier signals were here, the same signals has to be considered. So now this will be my x of k and this will be my h of k. Okay, understanding? Okay, now I will retain this x of k as it is, but I will fold this signal h of k. If I fold this, what I'm going to get? If I'm folding the signal h of k, what I'm supposed to get?
H of minus k.
H of minus k. That means what? Whatever is there on the right side, it will come to the left side. Whatever is there on the left side of the n is equal to 0, that is going to come on the right side. It is just something like a, you are keeping mirror at n, exactly n is equal to 0. So whatever the signal here, right side is there, it will reverse back. So whatever is here, it will come like this. Do you agree? Yes or no?
Yes, sir. Yes, sir.
Okay. Now see here. I want to find out y of 0. What is y of 0? N is equal to 0. So it is nothing but summation over k is equal to minus infinity to infinity x of k into h of 0 minus k. So what is that? This is nothing but summation over k is equal to minus infinity to infinity x of k into h of minus k. Do you agree this?
Yes, sir.
Okay. Now see here. Here h of minus k is there. Here x of k is there. Can you multiply these two and add sample by sample? You should do the multiplication sample by sample. Whatever the sample is existing at k is equal to 0, that should be multiplied with the sample existing at the k is equal to 0 here. Whatever the sample is existing at k is equal to minus 1, that should be multiplied with the k at the minus 1. Like that, you should multiply and then you have to add all those samples. Then you are getting y of 0. Okay. That means what you are supposed to do? Consider both the signals and transform them in the k domain. Independent variable should be made as a k. Then you fold the impulse response to find out the h of minus k. Then multiply x of k and h of minus k and add the sample by sample. So you will get y of 0. Next, keep the x of k as it is, but I will do h of n minus k. See here, what is h of n minus k? If n is positive, after folding, what you are supposed to do? If it is n is positive,
Delay, sir.
you should shift it towards the right side. If n is positive, you should shift the h of minus k towards the right side by an amount of the small n, whatever the n value is there. Suppose if I want to find out y of 1, then n will become 1. So shift the folded signal. You are not supposed to shift the unfolded signal. You are supposed to shift only the folded signal. Which is the folded signal? H of k. That folded signal is now h of minus k. You have to shift the h of minus k towards the right side by an amount of 1 if n is equal to 1. Now you shift it. What based on the n value, you have to shift it. If n is negative, then you have to shift the signal to which side?
Right.
Huh?
Right. N is negative, then right.
So no, already I have folded the signal. Already I have done the folding of the signal. Understand? It's not just a shifting. Already you have folded the signal. So you have determined h of minus k. Now this signal should be shifted based on n. Once if you have done the folding of the operation based on this n, you should be very careful. I think it was Anaga who told it, when n is positive, you have to shift it towards the right side. See here, whenever n is that value is negative positive, in normal shifting you have to shift it towards the right side. Okay, here when the signal is folded and if you want to shift it, shifting value is positive, then you have to shift it towards the right side. Anaga,
Yes, sir.
it's a reverse operation, you have to be very careful.
Sir, when it's negative, then we'll shift it to left, no, sir.
Yes, whenever
That's what I
n is
told.
whenever n is negative, we have to shift it left
Left.
side. Okay, then you
Yes, sir.
multiply. Suppose assume that you want to find out y of 1. Y of 1 is x of k is as it is. Here you will find out h of 1 minus k. H of 1 minus k is nothing but whatever h of k is there, it is shifted towards the right side by an amount of 1 sample. Then multiply sample by sample of h of 1 minus k and x of k and add them. That will give you y of 1. The reason is the formula. Where is that formula? Here. So if you want y of 1, this is nothing but summation over k is equal to minus infinity to infinity x of k into h of this n will become 1 minus k. Now similarly, if I want to find out the y of minus 1, what is y of minus 1? This is summation over k is equal to minus infinity to infinity x of k into h of minus 1 minus k. So already you are having h of minus k. This signal, which side it should be shifted? This should
Left.
be shifted towards the left side.
Left.
Okay, then you will be getting minus 1 minus k. You have to shift the h of minus k towards the left side by an amount of 1 unit. Then you will get h of minus 1 minus k. Then sample by sample multiply h of minus 1 minus k with the x of k and add those samples. Multiplied samples should be added together so that you will get y of minus 1. This is the procedure to find out the convolution. Understood? No? Yes? No response at all? No response?
Sir, so we should find y of 0 and y of minus 1, no, sir, following this method.
Yes, y of
That's
minus
all.
1, y of minus 2 or y. See here, I will tell you the range also. In the next period, I will tell you the range also. Over the what range it will be existing. That I will explain you. No need to worry. Okay. Now you understood what we are supposed to do. Given two sequences,
Yes, sir.
you first x of n should be considered x of k. H of n should be considered as the x of k. Just only thing is n independent variable is replaced as the k. Then you fold h of n, h of k, so that it becomes h of minus k. Then based on the your y of 0 or y of 1 or y of 2, whichever the value you want, you have to shift it based on that n value.
So basically here your k takes values from minus infinity to infinity, any values.
Yes, but normally it takes that k takes only non-zero integer range, non-zero sample value range.
Okay.
This is ideally we are talking ideal case. We are assuming that my signals are both sided and they are existing from minus infinity to infinity. But every time they will not be existing from minus infinity to infinity, no?
Yes, sir.
Okay.
Yes, sir.
So over the range we have to find out.
Yeah, no, that only my question also. In a given range, k takes any value in that range except 0.
Yes.
Okay.
Okay. But theoretically it is minus infinity infinity. Okay.
Yes, sir. Yes, sir.
I know that this concept is slightly difficult to understand in a one attempt. Okay, when we'll solve some problems, then you will be able to understand. Okay, now assume that we will consider the same thing. What is that? I know, assume that my h of n is like this: 1, 0.5, 0.25 and 0 and so on. The earlier problem, whatever we have considered, this is my x of n, sorry, h of n, and I will consider x of n is equal to 1, 1, 1, only this much. Already we have solved this problem. Okay, now what I will do, I will consider x of k. This is 1, this is also 1, this is also 1, 0, 1, 2. At 3, 0, at minus 1 also it is 0. Do you agree? Now I am having h of k. How is my h of k? My h of k is one at n is equal to 0, at n is equal to 1 it is 0.5, at n is equal to 2 it is 0.25, and 0 at n is equal to 3, and 0 at n is equal to minus 1 also. Sorry, not n, k. Okay. Now what is the first step? What we are supposed to do?
Fold h of k.
Fold h of k. So if I fold this, I will be getting h of minus k. So how will be your h of minus k?
Sir, sir, both of these h of k and x of n are given to us, no?
Yes, they are given. I have given to you both.
Okay. Okay.
So if you consider h of minus k, just you are keeping mirror at n is equal to 0 here. Whatever here is there, you are keeping the mirror. If you are keeping the mirror, so this 1 will be existing there itself at n is equal to, sorry, at k is equal to 0. Then where this sample will go? It is something
Minus
like
1.
at k is equal to minus 1. Yes, at k is equal to minus 1, you are getting 0.5. At k is equal, and what about this sample? This sample will go at
Which one, sir?
this one.
0.25.
0.25.
Minus 2.
At k is equal to minus 2, this will be 0.25. It will be like this. Okay. Now if I want y of 0, I am not shifting anything, just I have folded. And can I multiply these two, x of k and h of minus k? Can I multiply these two?
Yes, sir.
Multiply them, sequence by sequence. Where you will get the non-zero product?
At 0.
At 0.
At 0. Okay. At k is equal to 0, you will get non-zero product. So this is 1, this is also 1. So 1 into 1 is how much?
1.
1 plus here at k is equal to 1, this is 0, at this is 1. So 1 into 0 is
0.
And what about this side? This side at k is equal to minus 1, this is 0.5, whereas this is 0. So what you are going to get?
0.
So that means what value you are going to get for y of 0?
1.
1 only. Because only one samples are overlapping, it is something like you are holding the h of k, you are holding this h of k onto this x of k. This h of minus k, you are holding onto the x of k. Then how many samples are overlapping? Only one sample. One sample is overlapping on another sample. That is a non-zero samples I am talking about. Next, suppose if I shift this h of minus k towards the left side, then assume that I'm going to get h of minus 1 minus k. H of minus 1 minus k. I hope you have done this substitution method. Have you determined the shifting signals by the substitution method? Dear students?
No, sir.
No? Okay. In the next period, I'll explain you by substitution method how to find it out. Okay. So that you will be able to realize or appreciate the concept of shifting when the signal is folded. Okay. Now, if I want to find out the h of minus 1 minus k, what is going to happen with respect to h of minus k? What I am supposed to do?
Shift it to left by 1.
Shift the signal h of minus k towards the left side by an amount of 1 sample. So, this 1 is going to come at k is equal to minus 1 and at k is equal to minus 2, 0.5 and at k is equal to 3, minus 3, it is 0.25. Okay. Now you multiply h of minus 1 minus k with the x of k. What you are going to get? Is there any samples, non-zero samples overlapping? Is there any non-zero samples overlapping? No. That means what? What is y of minus 1?
0.
0. Suppose if I shift it still towards the left side, what I am going to get?
0 only.
0 only. That means what? My y of n is equal to 0 for n less than 0. Yes or no? Is it making sense?
Yes, sir.
Okay. That means even if you shift this h of minus k towards the left side, whatever may be the amount of the shifting or whatever may be the amount of samples you're going to shift, you will not get the any non-zero overlapping samples. So ultimately your y of n will be 0 for n less than 0. Now I will consider y of 1 minus k. What is y of 1 minus k? Sorry, not y. h of 1 minus k. What is my h of 1 minus k?
Shift it to the right, sir.
Which signal should be shifted towards the right side?
H of minus k.
H of minus k. Then where this sample will go? This sample 1?
At 1.
At 1. This will go at k is equal to 1. This 1 will come to here. This 0.5 will come to here. This 0.25 will come to here. So at k is equal to 0, this is 0.5. At k is equal to 1, this is 1. At k is equal to minus 1, this is 0.25. Now you multiply x of k and h of 1 minus k. You multiply x of k and h of 1 minus k. Then find out y of 1.
Sir? So sorry, sir, but why did we find h of minus 1 minus k here?
Just to check what will be the values for n less than 0. I want to find out y of n for n less than 0.
Oh, okay. Oh, it will be 0.
Nobody has told it is going to be 0.
Okay.
That I am supposed to ensure it. Yes. Is it right? I'm supposed to check for all the values of n,
Okay.
Understanding?
Okay.
Okay. Now you tell me, you take the product of h of 1 minus k and x of k. Is there any overlapping of the samples?
Yes, sir.
How
Yes,
many
sir.
samples are overlapping?
2.
Samples. So multiply them.
Is it 1.5?
1 is 1 into 1. So 1. Another one is at k is equal to 0. It is 0.5 into 1. So 0.5. 1. So our answer is 1.5. Now can you find out h of 2 minus k? Suppose if I want y of 2, y of 2 is summation over k is equal to minus infinity to infinity x of k into h of 2 minus k. What is 2 minus h of 2 minus k? It is nothing but h of minus k shifted towards the right side by an amount of 2 units, 2 samples.
1.75, sir.
So
1.75.
1.75. Okay, next y of 3. You have to shift the h of minus k by an amount of 3 samples towards the right side.
Point 0.75.
I have to check it. I don't know.
Yes, sir. 0.75.
H of 3 minus k. 3 minus k means whatever is there at k is equal to 0, it will come to 3. At k is equal to 0, at h of minus k, at k is equal to 0, it is 1. So that will come to 3. At 2, it is 0.5. At k is equal to 1, it is 0.25. So now you take x of k and h of 3 minus k. So how many samples are overlapping? One is at instant n k is equal to 1 and another instant k is equal to 2. So these two are overlapping. So that is 1 into 0.25 plus 1 into 0.5. So it is 0.75. Okay. Next for n is equal to 4. If you find out h of 4 minus k,
0.5.
0.25.
0.25.
0.25.
0.25. It is 0.25. Then for n greater than 4,
0.
0.
0. That means your values are for n less than 0, it is 0. At n is equal to 1, it is 1.5. At n is equal to 2, it is 1.75. Next 0.75. Next, how much it is? What is y? Oh, sorry. Y of 0 is 1, 1, 1.5, 1.75, 0.75, and 0.25. This is at n is equal to 4. For n greater than 5,
0.
for n 0, it will be 0. Graphically, have you got the same answer what we have got it in the earlier?
Yes, sir.
So this is another method. It's a graphical method. So it's a graphical method of finding out the convolution. Please tell me, all of you are able to understand or not?
Sir, what will be the value at y at 5?
You check it. You have to find out h of 5 minus k. You find out h of 5 minus k and multiply with the x of k. What you are going to get?
Sir, I think it will be 0. Okay.
Yes, it will be 0 because there is no overlapping samples. Okay, non-zero overlapping samples will not be there.
Sir, in the exam, they ask a question like this. I suppose to sit and draw all the graphs for h of 1 minus k, h of
Yes,
2
yes.
minus
If
k.
they ask you to find out the convolution using graphical method, you have to do like this. If they don't specify the method, it is up to you. You can use the formula method also. Okay.
Which for the summation method?
Yeah, summation method.
Okay, sir. Yes, sir.
Any doubts?
So, but what if they gave a graph, but they didn't tell you it should be in a graphical form?
Even if they give the graph and if they did not tell anything, you are free to use any method. See here, unless otherwise specified, you are free to use any method.
Okay.
Clear?
Yes, sir.
At this point, shall I stop? In the next period, I will give you the range, how to find out the range for the given problem.
Okay, sir.
Okay. Just please try to go through the notes, whatever I have given today. Try to understand it properly. In the next period, still I will explain the method in a more detailed form. how to consider the values, what will be the range of n for y of n when given x of n and h of n, how to find out the length, all other things I will explain you. At this point, I'll stop. Anybody else is having any sort of doubts? Please, you can ask. Shall I wind it up for the day?
Yes, sir.
Okay, thank you.
Thank you,
Thank you.
sir.